Let's imagine we're given the work function of a metal, which is the amount of energy that is required to liberate or release or free electrons from its surface, and then asked to find the threshold frequency of that metal. For example, let's find the threshold frequency of the metal cesium. Let's assume that the work function of cesium is about 2.1 electron volts. The Planck's constant is obviously 6.63 times 10 to the power of negative 34. And the threshold frequency is what we're looking for. The question is, what is the threshold frequency of cesium? First of all, the equation that we should be using in this problem is phi, the work function, is equal to h times Fo, where Fo is the threshold frequency and h is obviously Planck's constant. Now, since we're looking for Fo, we are going to rearrange this equation for F. So I'm going to have to divide both sides by h, and Fo is equal to phi over h. Fo is simply equal to the work function, which is in electron volts. I have to convert that into joules. So 2.1 times 1.6 times 10 to the power of negative 19 divided by Planck's constant, 6.63 times 10 to the power of negative 34. 2.1, let me calculate that, times 1.6 times 10 to the power of negative 19. I get 3.36 times 10 to the power of negative 19 on the top, divided by the bottom. I get a frequency of 5.06 times 10 to the power of 14 hertz. And that would be the threshold frequency of cesium. Thank you for watching.